So for 13, they want us to find the slant asymptotes and the vertical asymptotes, then sketch the graph. So slant asymptotes, these are also called oblique asymptotes, or they could be called diagonal asymptotes. And essentially they're diagonal lines that are boundaries in the function. So they're not vertical lines, they're not horizontal lines, they are diagonal lines. And to find these, we actually use long division. So if I do long division here, x squared minus 3x minus 4, and I'm dividing x plus 2 into it, I would ask, what do I need to multiply x by to get x squared? And that is an x. So then I'm going to multiply x by the x plus 2 and get x squared plus 2x. And then I want to subtract those. So the x squareds are going to go away, and I'm going to get a negative 5x. I would bring down the negative 4, and then I would restart the process. So what do I need to multiply x by to get negative 5x? And that would be a negative 5. So negative 5 times x plus 2, this is going to be negative 5x minus 10, and then I want to subtract these. So the negative 5x's go away. Negative 4 minus a minus 10 is 6. Now something very interesting about this process is we actually only care about this part here. We actually only care about the x minus 5. So my equation for the diagonal asymptote is going to be x minus 5, or y is equal to x minus 5. The 6 I actually do not care about. I don't care about the remainder. So there's not many things in math where we just don't care, but this is one of those cases. So only look at the answer from the long division, and that's really all we care about. Now, they also want us to find the vertical asymptote. So again, to do that, you would set the denominator equal to 0. So I have x plus 2 is equal to 0, or x is equal to negative 2. So these are the two asymptotes that they want us to graph. We have the diagonal asymptote at x minus 5, and the vertical asymptote at x is equal to negative 2. So on your calculator, and the window that I used for this is negative 20 to 20. That worked. You could probably use a different window. But I had really the two asymptotes, and your picture doesn't need to be perfect. And I had a diagonal one that looks like this. So you can actually graph the equations of the asymptotes. And then if you graph the function itself, it's going to look kind of like that. Okay.